Hi and welcome to the first video on PLpgSQL, the stored procedure language used by PostgreSQL. Now remember that PLpgSQL is Postgres specific, but it closely mirrors Oracle's PLSQL, so it's quite a useful language to know anyway. And I should point out that neither PostgreSQL nor Oracle actually follows the standard, but Oracle's so widely used, knowing a language that's relevant to Oracle is probably useful. Okay, so I prepared a whole bunch of functions at gradually increasing levels of difficulty, so we'll just start looking at them. And I've got a little database as well. So first thing, you can check out what functions are defined in the database by going \df. These are the functions that I'll be talking about, and you can see that some of them return single atomic values, some of them return tuples, some of them return sets of atomic values, effectively a table column, and some of them return sets of tuples. In other words, they return a table. So let's take a look at the definitions of some of these functions. Okay, the first one is very simple. It's a function to add two numbers together. And I decided to do it two ways, to point out that PostgreSQL allows you to define functions in several different languages. So the first version of the function defines the addition in SQL. The second one defines it in PLpgSQL. Okay, so for an SQL function, all you have to do is write a single SQL statement inside the body of the function, where the body is all the stuff enclosed in the $$ symbols. And the result of the function, or the return value of the function, is simply the result, or the final result of that SQL statement. Okay, should have looked at the signature of the function first. So this is a function whose name is add2a. It takes two integer parameters and returns an integer result. And the parameters are used in the body of the function here, simply using PostgreSQL's built-in addition to produce the final result. So you can execute that as follows. Let's quickly take a look at using it. So select add to A3 and 5, and it gives you 8. Now of course you could have equally well done it like this, but really the point is that we're trying to illustrate how to write functions in PostgreSQL. Alright, so let's go back to and look at the second function. Now one thing you should notice straight up, the name is different obviously, but the rest of the signature is exactly the same. This is a function that takes two integer values and returns an integer result. Okay, so PLpgSQL functions are defined like this with begin end. Now PLpgSQL and Oracle's PLSQL are kind of old-fashioned programming languages in that they use keywords to bracket chunks of the code, rather than modern languages which tend to use smaller symbols like braces. So we see that the body of the PLpgSQL function is enclosed in begin end. At some point in the function you've done some computation and you want to return a result, so you need to use a return statement, and here we're simply returning the result of the expression a plus b. So once again we're using the parameters inside the body of the function to compute a result. Now this one's also loaded into that same database, and except that it's called add2b, and it does the same thing. If I tried to add three numbers together, Postgres will complain and tell me that there's no function called add2b that has a signature like this. So there's no function called add2b that requires three integers as inputs. I could easily define one, A integer, B integer, C integer, and then do the addition that way. So yeah, pretty straightforward. Another important thing to note about these functions is that they actually don't reference the database at all. And such functions in PostgreSQL are called immutable. So whatever the current state of the database, if you feed in the same values of A and B, in other words, if you feed in, say, 2 and 3, you're always going to get the result 5, regardless of what's currently stored in the database. So in some sense, the function behaves like a mathematical function. Okay, so let's go on to the next function. And here's a function that returns a single tuple, doesn't return a single atomic value. And also doesn't require any database access. So once again, this function is immutable. Now, has similar kind of input parameters, 2 integers, but this time we can see that the result it returns is a tuple type. So generally we need to define these tuple types, and here's an example of using PostgreSQL's create type statement to define an appropriate type. So we're defining a type whose name is pair, and a pair consists of 2 integers. The first integer value is called x, and the second integer value is called y. So we're going to return tuples of type pair where each tuple contains an x field and a y field. Okay, so it's a PLpgSQL function. We can see that down here. So let's check out the body of the function. Now, unlike what we had before, we've got a local variable declaration. So in the previous example, we didn't have to define any local variables. So now what we're doing, we're defining a variable whose type is pair. In other words, P is an object that has an X attribute and a Y attribute. And so all we're going to do is take the values that we feed in, assign them to the appropriate attributes in the P tuple, and then return that P tuple as the result of the function. So let's take a look. So we're going to make a pair, and let's once again pick the numbers 3 and 4. And what gets returned to us is a tuple containing 3 and 4. Now, with Postgres, you could return a tuple like that, or you could pretend that you're dealing with a table that has a single tuple in it and run the query like that. So that'll tell you that the attribute names are x and y, and the value of x is 3 and the value of y is 4. So this would be the more normal way that you'd use queries that return tuples. Whether they return a single tuple or a set of tuples, you tend to use them in this kind of context. They'll still work in this kind of context, but this would be the normal expected way of using them. Alright, now let's take a look at the next function. And this is a function that returns a set of values. Okay, so in some sense, and since the values are atomic, it's like a table column, if you like. Okay, so this is a function, and you might recognize this from the activities, so I'm kind of giving you a hint. In fact, I'm giving you the solution, but the sequence function called sequence, we give it a high value, which is of type integer, and it returns a set of integer values. Okay, so clearly to do that, we're going to need to generate a sequence of values, and the assumption here is that the sequence starts from 1. So we're going to need a local variable, which is going to be used effectively as a loop counter. We initialize it to 1, and here's an example of defining loops in PLpgSQL. So it has while loops and it has for loops. We'll have a look at a for loop in a minute. So while loops, continuation condition, so while I has a value that's less than or equal to the value that was fed in as the parameter, we run the loop. So as I mentioned before, PLpgSQL is a little bit old-fashioned in using keywords rather than braces to surround the body of a loop. Anyway, inside the body of the loop, one obvious thing that we'd expect to do is to increment the value of the loop counter by 1 each time through the loop. PLpgSQL doesn't have any equivalent to C's I++, so we simply have to write the assignment statement like that, and it also uses colon equals for assignment, which once again is a little bit old-fashioned. Okay, the other important thing, very important thing here is that how do we return a set of values? Well, we generate the values one at a time, and we use this construction here, return next, to, if you like, add the current value to the set of output values. So return next will add a new result, then we go around the loop again, return next adds another result, and so on and so on. Technically, we don't need this return at the end of the function. The function will just return anyway, but all of the examples in the PostgreSQL documentation seem to use this, so I'll put it here. So in case you're looking at the Postgres documentation, you'll see that kind of thing. So hopefully the loop structure is pretty straightforward. I equals 1, I less than or equal to the high value, I equals I plus 1. For each I, we return that I as the next tuple in the result. Now in this case, the tuples in the result are simple integer values, so we don't need to define a tuple type. In fact, this could be any PostgreSQL type, but here it's just a simple integer. So let's take a look at how that one might work. Now, since we're returning a set of values, it wouldn't really make sense to say select sequence here. So what we're going to do is let's take the first 13 integers, and so it will produce a result like that. I can make 13 arbitrarily large or arbitrarily small if I make it 2. Oops. And finish off the brackets properly, then it will give me the first 2 integers. If you insist on trying it like this, then here's what you get. So you get effectively the same thing, in fact. So it still looks like a table. Okay, so that's a function that returns a set of values. Obviously very important in the context of interacting with the database and collecting sets of tuples. So let's now have a look at a function that returns a set of tuple values. Okay, pair is the tuple type that we defined earlier. So this function is going to return a set of pairs where each pair contains a value and that value squared. Okay, none of these functions are particularly useful, but they serve to illustrate the basic mechanics of defining functions in PLpgSQL. So once again, function is called squares. It has a single integer input parameter and returns a set of pairs as its result. Okay, same kind of structure as we had before, some variable declarations at the start. So we're defining a pair variable and a simple integer variable, and now we're using a different structure to generate a set of values. So PLpgSQL has for loops, and this is effectively, the kind of thing you'd see in C for I equals 1, I less than or equal to I plus plus. That will generate the values 1 up to I inclusive and assign each of those in turn to the I variable. So what do we do each time through the loop? We set the values of the attributes in the pair. So we set px to the current value of I and py to the current value of I squared. And then we've generated a result tuple that we want to return. Because we're going to do that iteratively, we simply return the current one as the next tuple in the result, go around the loop, then return the next tuple, next tuple, next tuple, and so on. And then at the end we've got this return. So let's take a look at how that works. Squares, let's take the squares of the first 10 positive integer values. So you can see that it produces something starting to look a little bit more like a database table. It has attributes with proper names. The x values increase by 1 each time. The y values are the x value squared. If, for example, we didn't like the names x and y at the top and we wanted to do something a little bit more sensible, then what we can actually use those attribute names and rename them using PostgreSQL's as mechanism. Let's do something like this. So we're going to rename the columns as n and n squared. Let's just take the first 5. So now you can see the columns have different names. Doing that was a little bit trickier with some of the examples that we were doing earlier, because we didn't actually have names for the columns. Anyway, if you're defining a function that returns a set of tuples, then you've naturally got the attribute names that you can play with. All right, let's take a look at the next one. Now, that's enough for functions that don't interact with the database at all. So I thought we'd take a look at one function that does interact with the database, and it returns a set of atomic values. We'll also have a look at another version of this that returns a set of tuples. Okay, so this function is we're going to use the pizza database that you've been using for some activities. And this function is going to return a set of pizza names for all pizzas that have a particular topping, where the topping is the argument to the function. So pizza with function name, the argument is just a text string, the name of the topping, and it returns a set of text strings where each of those text strings is the name of a pizza. Okay, so for this example, I've started using a convention that I mentioned in the notes, and that's to name all of the objects, local objects, parameters and local variables inside the function using an underscore, so that they don't get confused with database related objects which have similar names. So here you can see that we've got an embedded SQL query that refers to something called P. If I'd called this P, there's potential for confusion. So if we name all of the local variables and parameters with a name that starts with an underscore, we're not going to have any confusion with database names, unless of course you insist on naming your database objects starting with an underscore. Alright, so this example here declares a local variable of type pizzas, so that's a tuple type, and makes use of a different use of the for loop in PostgreSQL, and that's to extract the results of a query one at a time. So here's our query. And this query is simply doing a join between the pizzas table and the topping table via the has table. So if you remember what has does, it says it's effectively implementing the relationship. A particular pizza has a particular topping. So we're simply joining those two tables. And what we're getting at the end is a pizza tuple effectively. So P in this query is an alias for the pizzas table. P dot star is simply the name of all of the attributes of the tuples in the pizzas table. Okay, so effectively we're getting a pizzas tuple here, and what's going to happen each time through the loop is the next pizzas tuple that satisfies this query is going to be stored in the underscore p variable. So each iteration of the loop, underscore p contains the value of the next tuple in the result. So we need to do something with that. Well, here what we're going to do, we're going to grab out the name of the pizza and return that as the next result of the function. Okay, remember that the function returns a set of text. So, and that's all it does. And here I've omitted the final return statement, but we could have added that if we wanted to. Now, in fact, this function has an error, and I wanted to load it up and try and run it with the error so that you can see the kind of potential problems that you can have with PLpgSQL functions. Okay, so let's go to that database and let's try and load it up. And if you remember, it's \I and the name of the file to load, and it says, oh, no data type pizzas in this database. And we say, why could that be? And we just look for the tables in the database, and we discover, well, this is a small database that's actually only been used for these functions, so we're in the wrong database. So what I have to do is run the pizza database, and then I can try that loading again, and this time it says it's created a function. Okay, so it was happy. There is a data type pizzas, which is a type of the pizza function. So now we can try to find all of the pizzas that are pizzas with a topping. Let's think of a topping. If I remember correctly, cheddar cheese is one of the potential toppings. Now remember, I said this function had an error. So up here we've actually loaded the function. We've loaded the text of the function into the database. Unfortunately, the text has an error. And the error is that I'd called the toppings table topping in the function definition. So a slightly annoying aspect of PLpgSQL, and in fact all of the other stored procedure languages in Postgres, is that you can potentially load functions that look like they've parsed correctly, which in fact they have, but they still contain errors, for example, referencing tables that don't exist. So to fix that, I could go back and edit the file, but I thought I'd show you something else. When you're inside PSQL, you can edit a function by using the \EF thing and typing the name of the function, and this will drop you into your favorite text editor. My favorite text editor is VI, so that's the one I get dropped into. That's the default. If you don't know how to use VI, you can change the editor by setting the editor environment variable. So the error was that I used an incorrect name for the table. So if I change that, so I'm in the editor editing the function, you can see that the appearance of the function inside the database is a little bit different. The body of the function is always the same. You can also see that it uses different kind of quotes around the body of the function. It uses dollar, some name, dollar. Alright, so having made that fix, I go out. I need to type semicolon to make it create the function again, and now I should be able to run it and get the names of pizzas that have cheddar as one of their toppings. And I guess we could try other toppings. Let's see what pizzas have garlic, for example. Well, apparently there's only one pizza with garlic. Okay, so that result was being produced by this. The other thing I should have mentioned when I was talking about this function before is that here we've got something that's effectively an SQL query, but it's getting some of its information from the environment of the PLpgSQL function. So you can see that underscore topping, it's using the value that's coming in as the function parameter. And that's one reason why I said that we should use underscores to name our local variables, because if I just called this thing topping, then there'd be confusion with that topping and it probably wouldn't work too well. Alright, so that function simply returned a column of data, the names of pizzas. What if we wanted to return all the information about each of those pizzas? Then here's a variation of that function. Looks not much different. The differences are it's got a different name. I've just added one to distinguish it from the previous one. And it returns, rather than a set of text values, it returns a set of pizza tuples. Everything else is pretty much the same, except rather than simply returning the name of the pizza, we return the entire tuple. So let's take a look at that one. So if I search for the pizzas that are pizzas with cheddar as a topping, then I get that result there. Okay, so I've fetched 5 pizza tuples. Previously, all I got was effectively was that particular column there. Now I'm getting all of the information about each pizza. If I wanted to get different information, then I could structure the output type of the function differently, and then I could return different collections of variables relative to that output type. So if you understand how to embed a query inside a for loop in PLpgSQL, the values here each time are bound to this variable, and then we do something with that variable to produce a result tuple in the output. You're well on the way to being able to do pretty much anything with PLpgSQL. Okay, so that's it for this video.